Welcome to Lesson 4, Video 1 for Unit 8, Strong Acids and Bases. So what we are going to do is we're going to look at those strong acids and strong bases that we talked about in the first unit, and we're going to apply our pH problems to different situations. So the whole thing about strong acids and bases, they completely ionize in water to form either H3O plus or OH minus. So we're going to tend to just talk about these in general together, but knowing that a strong acid ionizes and a strong base ionizes both 100%, the same thing if we talk about an acid applies to a base. So if we have a strong acid like HCl and we add it into water, the HCl fully separates. So the H plus leaves and forms our hydronium ion with the H2O. So this is the acid, this is the base. So we end up with Cl minus and H3O plus. So here is the conjugate base, here is the conjugate acid. Now, if we start looking at this and we have 0.100 molar HCl, if it fully ionizes, and we're not going to write out an ice chart, but this would decrease by 0.100 molar. So initially we would have this, we'd have 0 this, and 0 of this. If this decreases by 0.100 molar, then at the end, these would increase by that amount. So we would end up with 0.100 molar Cl minus and 0.100 molar H3O plus. Well, this we can use to find pH. But we run into a snag if we have something like H2SO4, or we have a base that has 2 hydroxide ions in it. So if we look at this one, we're going to end up with 2 H3O plus on this side and SO4 minus 2 when this one balances out, because we're going to have 2 different ionizations for this. So if we have 0.100 molar H2SO4, we have to double that for H3O plus. So we end up with 0.200 molar of this and 0.100 molar of SO4 minus 2. So this then can be used to find pH. So the whole thing here is look at the number of H in the acid or OH in the base. We're going to multiply the molarity by that number to give the OH minus or H3O plus concentrations when it ionizes. So that's the basic gist of what we are going to do with these problems. We're going to break things down. So you have to know the formula of something in order to figure out its pH, POH, H2O plus, OH minus. So if we look at our first example here, find the H3O plus concentration and pH for 0.500 molar sulfuric acid. Sulfuric acid is H2SO4. So this has 2H, so that means that we have to multiply the molarity of H3O plus by 2. So if it's 0.5 molar sulfuric acid, 0.500 molar times our two H's gives us 1.00 molar H3O plus. So that's one of our answers. Now pH is equal to the negative log of 1.00, which gives us a 0 pH. Let's look at our next example. Find H3O plus and pH for a solution made by dissolving 85.0 grams of HCl in water to form 3 liters of solution. So we're making hydrochloric acid. So this ends up being a molarity problem and a pH. So we're taking things from last unit and bringing them in and applying them with pH. So we have to find the molarity of HCl. So we need to know the formula mass of HCl because we need to know how many moles it is. So it's 36.46 grams of HCl in 1 mole. And then we have 3.00 liters. So now our grams of HCl cross out. We're left with moles of HCl over liters, which is molarity. That gives us 0.777 molar HCl. There's only one H in HCl, so that means that we have 0.777 molar H3O plus. So there's one of our answers. And pH is equal to the negative log of 0.777, which gives us a pH of 0.110. We'll continue our example problems in subsequent videos.